In this lesson, we are going to be talking about inverse functions. This is part one. We'll probably have about 3 videos on this. And so in particular, in this lesson, our goal is to understand the definition of inverse. Given a relation, we'll be able to determine the inverse. Given the graph of a relation, we'll determine the inverse graphically. And then we will also graph a relation and its inverse. Okay, so today, this lesson is all about getting acquainted with the idea of what an inverse is. So an inverse relation is obtained by interchanging x and y, or another way to think of it is if x is our input and y is our output, we interchange the input and output. Okay, so this could be coordinates. So for instance, if we had a coordinate 2, 1, the inverse would be 1, 2, interchanging x and y or interchanging the input and output. If we're given an equation, something like y equals x plus 5, the inverse would then be x equals y plus 5, and we'll talk about that a little bit more as we go through the lesson. Okay, so what an inverse is it's a reflection across the line y equals x. So if on the first slide, my icon at the top, this is a graph, and this dotted line here is y equals x. So when we talk about a reflection, if we've got a point here, if we were to fold this along the line y equals x, and I think of the dotted lines of like fold here, cut here, the image would be right here. Okay, so this is the reflection across the line y equals x. Okay, so let's get started. So example 1a, so visualizing an inverse relation. So given the relation G, graph G and the inverse of G. So first we're going to start by graphing G. This is a set of ordered pairs, and I am going to graph G in green. Okay, so G is going to be in green. So we have 2, 4, 2, 1, 2, 3, 4. We have -1, -3. And we have -2, 0. Okay, so G is in green. Remember, we are doing a reflection across the line y equals x. So y equals x, if we think of mx plus b, our b is 0 and our slope is 1. Okay, so it looks like this. Okay. So we're doing a reflection. So I'm going to graph the inverse of G then in purple. So if I reflect this first point at 2, 4, I'm going to end up here. Okay, so it's been reflected across the line y equals x. Same thing for -2, 0. It would end up here. Okay, so what I'm doing is I'm imagining I'm folding this along the line y equals x, and then the purple is the image that's on the other side, okay, or the corresponding point with the reflection. And my last point, if I reflect 1, -3, it would go here at -3, 1. Okay, so these purple dots represent the inverse of G, the inverse relation of G. Okay, and then we can also determine it by interchanging x and y. So the notation for inverse, which we'll get into a little bit later, is G -1. Okay, that's just the notation for inverse. So we'd have, instead of 2, 4, we would have 4, 2. We interchange x and y. Instead of -1, -3, the inverse of that is -3, -1. And then for -2, 0, if we interchange x and y, we end up with 0, -2. And if you look on the last slide, we had 4, 2, 0, -2, and -3, -1, exactly what we just determined here. Okay, next, we're going to reflect a graph to determine its inverse. So we are given the graph of x equals y squared plus 2. So that's in red. And we are supposed to reflect it across the line y equals x, that's our dotted black line, to obtain the graph of its inverse relation. So again, imagine that you're folding this along the dotted line, and what you're graphing for its inverse is the corresponding image that happens when you fold it. Okay, another way to do it is to look at some ordered pairs. So for instance, there's an ordered pair here at 1, 0. So for the inverse, it would be at 0, 1. There's a point at 5, 2. So there's a point at 2, 5. Okay. And there's a point at 5, -2. So there's a point at -2, 5. And if you connect this, I'll draw it in purple. And this is what we'd have. Okay. So the purple is the reflection across the line y equals x. This is the inverse relation of x equals y squared plus 2. Okay, so determining the equation of an inverse relation. So remember we talked about we interchange x and y. So for the equation, we would put y equals x squared plus 2. So this would be the equation of the inverse. And if you notice, this is a parabola that's been moved up 2 units. Okay, that's exactly what we just graphed on the previous slide. Okay. So given the graph the equation, then reflect the graph across the line y equals x to obtain the graph of its inverse. So we have y equals absolute value of x plus 3. So there's a couple different ways you can graph this. A few lessons back, we talked about function transformations. So we can start with the graph of y equals absolute value of x and then move it up 3. This is a vertical shift going up 3. The other thing you can do is make a table of values. I would say 3 is typically safe. Okay, so if we plug in x is -1, and for x, we'd have the absolute value of -1 plus 3, which is 1 plus 3, which is 4. If we plug in 0, we get 3, and if we plug in 1, we get 4. So the graph of y equals absolute value of x plus 3, we have a point at -1, 4. We have a point at 0, 3, and we have a point at 1, 4. Okay, and remember this is a V graph. Okay, and we're reflecting it across the line y equals x. So you can do it visually by folding, or you can take each x and y and interchange it. So rather than a point at -1, 4, the inverse of this would be 4, -1. This would be 3, 0. This would be 4, 1. I like to do points because then I know it's exact, and then I check it visually. Okay, so this is what I have. I double check. Does it look like it's been reflected? It does. Thank you for watching. If you have any questions, feel free to reach out to me.